Alright, welcome back. We're just going to be doing some linear regression today. Essentially what we have is, we've got some ordered pairs, we've got some points here, these are all these x's, and we'd like to find the equation of a line that is best through all these points. So in essence, let's go ahead and get started. I've decided to go ahead and make this pretty simple on you. So let's go ahead and just use, recommend using this site right here. You could use this on a graphing calculator. There's really a lot of software out there. However, this site's going to be what I'll be doing the demonstration with. So it's just you might want to go ahead and pause that and copy that down, and we'll go ahead and use that. So Chapter 7, Linear Regression. It's really not going to be that bad. So I'm going to go ahead and post these so you can go ahead and work through them. But here's how this works. They'll go ahead and give us a chart, and it says here's some interest rates for an economy over several years. So what we notice, we've got the years on the left-hand side here, and we've got the interest rates on the right-hand side. And interesting to know, get rid of that. What are they asking us for? They are asking us for the predict what interest rate will be in 2015. So what we're asked to predict are the interest rates. So this tells me that the interest rates are my y. So it's all about what you're predicting. So the interest rates on the right-hand side are my y. The years on the left-hand side are my x's. So what you'll end up doing is you'll input all these data. You have all these ordered pairs. Essentially what you have is 2000, 3.06. That's one ordered pair, and that'll be one plot. You'll have 2001, 3.5 or 3.50 if you prefer. That'll be another ordered pair. And then you take the next one, right? You take this ordered pair, 2002, 3.55. Essentially, you're going to want to write down every single one of these. There are 10 of them. Once you go ahead and do that, and you want to write it in x, y. That's very important. So I've done that over here. Already done that. So let me go ahead and copy this down and show you how this website works. So let's go to this website now. What you'll see when you first get there, you'll see something that looks like this. Statistics calculator linear regression. It says enter x, y values. So again, the predictor we want to put on the right. So we're predicting the interest rate, so that goes on the right. The independent variable, what we're putting in, are our years. So go ahead and enter that. Click submit data. You should get something that looks like this. It tells you your sample size, your mean, your intercept, your slope, and most importantly, your equation of the line. So here they've got x's here. You can just confirm that indeed your x's were the years, and what you're predicting are these interest rates on the y-axis. And you can see why are you predicting y, because it gives you this equation for y. So if you want to predict y, of course, what's going to happen is when it says use this equation to predict something, you copy that equation. You can either Control C or you can right click on it, select copy. Either way. So the equation over line ends up being this sort of thing. Okay, so ignore B. We're not going to do anything with the R squared in this class. It says use your model for part C, however, to predict what the interest rates will be in 2015. What they really want you to do here, instead of this X, we'd like to replace that with 2015. So you could manually type this in, 0.162 yada 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 times 2015, and then get that, subtract off this other number, get your answer, and that would be your prediction, y equals. You'll also notice on this site, you have this nice section right here for enter an x value. It says predict what the interest rate is in 2015. So I can just type in 2015 and hit calculate. Will give me this sort of value. And we'll talk about, this is really not a good year to predict, and we'll talk about that a little bit later. Generally speaking, you take your highest year from 2000 and 2009. We like to predict things inside of our data rather than outside. But this is just a nice example just to show you. Alright, so let's go back to our document. So we predict that essentially our interest rate would be about 5.64%. Alright, let's do the next one here. Next one is use the information collected on 14 students and consider the connection between study time and performance on the math section of the SATs. So in essence, we would sort of suspect that the longer we study, the better our score will be. So again, what are we trying to do? We're trying to predict the math score. So the math score is our y, and our study are our x's. So again, out to the side, what you'll end up typing is you'll type 4,390, and you'll type in all of these 9,580. You'll type in all of these. And again, the reason you do this is because it's x comma y. If for whatever reason I had these switched, these columns switched, and had y and x, again, then you would want to put these numbers on the right-hand side first, comma, these numbers on the left-hand side second. And I think I may have done that on the final exam. So you're going to want to really just kind of double check, see what you're predicting. Okay, so once you actually do go ahead and copy this big section down, there's a lot of data here. I've done that out for you. Got this over here. So I'm going to copy this. Once you've done this, you can find, if you scroll down, it just says submit data or reset. So we'll reset because we're going to do another one. If you prefer, you can just type the data directly in here. I have just done it this way to make things quicker on the video. So let's go ahead and submit our data, see what we get. Alright, so here we go. We've got some hours studied on the bottom here, 0 to 22.5, and scores on the SATs on the left-hand side. So the equation of our line is given to us right up top here. So that's what we're looking for. When it says find the equation of the best fit curve, or the best fit line, we're talking about this. So the least squares best fit line for predicting the student's test scores in math is given as this. Does the model seem like a good fit? That question is just sort of asking, well, essentially, do these x's sort of look like they are generally on a line? For instance, we don't have any other patterns. They're not very far from a line. It looks appropriate there. Use the model to estimate a student score who studied 15 hours. Alright. And this is going to be a lot better because it lies within our x's. So in essence, what you could do is you could manually replace this x with 15, and you could multiply this all out and get your y. Or you could go ahead and go to the site, type in your 15, and have it calculated for you. So it's saying about 700. So that seems alright. The student who studies 15 hours would get about a 700 on the math section of the SATs. Alright, so that seems okay. And the danger here, this will kind of show you, what if we use this to predict, what about 100 hours? You go back here and type in 100. It predicts on the math section we get 2,685. But of course that's not very accurate, because if you know the SAT, the most you can get on the math section is an 800. And that's sort of the danger with predicting far out to the right here versus picking this 15 and just picking this point on this line. This is about 700. Alright, so we're going to keep it pretty simple there. What you can expect to see, some kind of chart like this. Again, figure out what you're predicting. It's not always on the right side. It could be on the left side. And write x comma y. Right? Your prediction is always your y. You'll go ahead and use this website that we went through, and you'll use that to find the actual best fit curve. And then you can also use that to find out your prediction values. So this will be really all we're going to do for Chapter 7 linear regression. Best of luck to you, and I'll see you, well, I guess I won't see you next time. So best of luck to you. Good luck.